Okay, so a natural log is a logarithm that has a base of e, and e is a number, okay? And that number has an approximate value of 2.71828, and it's got the dot, 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 which means that continues on forever without repetition, much like pi does, okay? You don't have to memorize the number. If we ever need to use e, it's in the calculator, okay? But just know that a natural log has a base of e, like a common log has a base of 10, natural log has a base of e. So sometimes they will write it with the word log, and they will write the base e in there of x. You still have your base, you still have your argument, you still have your exponent. Okay? But most of the time, and the way you will see me write it is like this right here. And that is an L, not an I. Okay, so when I write it, I'm going to write it like this, the natural log, so that you can kind of tell that's an L. So the natural log of x, that means the base is e. Okay, it's just not going to be written, much like the common log of base 10 is not written. So when you see that ln, that means it's a natural log, and your base is going to be e. Okay, that's ln, not in. Why do they call it ln instead of nl? I don't know. That's just the way it is. I get that question every year. Why don't they call it nl for natural log instead of ln? I have no idea. Again, all the other rules apply. So we're going to start by just changing it from log form to exponential and exponential to log, like we did when we first started logs. Okay, same process. You're still going to make your E and you're still going to make your L. Are I ready? Not quite. Okay, just a second. You're good.
You said L, E, not I.
Right. It's an L, not an I. All right, so again, we're going to just start with the basics like we did with the regular logs. We're just going to take it from the log form that it's in now to exponential. Remember, anytime you see that ln, that is a natural log, and your base is not going to be written, but it is e. So we're going to take the natural log of 100 equals 4.61, and we're going to take it to exponential. So what I would recommend is going ahead and writing your e in there so that we know what our base is. And then just like we did with regular logs, we're going to make our little e to take it to exponential, starting with your base. So it's going to be e to the 4.61 power equals 100. We're not trying to do anything else to it. We're just taking it from one form to the next. And the way that second one looks is not right. You see how that -2 looks like it's up higher? It should not be. I need to retype that. It should look like this. All of that should be in line, not raised up. I'll need to go back and retype that. Okay, so once again, we're going to take it to exponential. Our base is e, but it's never written when it's in natural log form. And then we're going to take it to exponential. E to the -2 equals 1 over e squared. And that's all we're doing for that one. Okay, from log form to exponential. Is everybody okay with that? Okay. So then we're going to go backwards. I'm going to give it to you in exponential, and we'll take it to log form. Take a minute and write those two problems down, and we'll talk about how to do that. I'll show you the first one, and then I'll let you try the second one. Oh, no, I'll have to do the second one. on number 3, what is my base? What has an exponent on it? What has an exponent on it? E. Okay, so we're going to do just like we did with regular logs. We're going to start above that base, and we're going to go the natural log base E of 1097. So I'm going to write ln. Let me write my cursive. ln. I don't have to write the base. If you do write the base, that is okay, though. If you want to put the E there, that is perfectly fine. And then that's going to equal, what number did I not touch? 7. Okay. So that's what it looked like. If you wanted to, you could write it as the natural log, put the base in there. That is also perfectly fine. But with a natural log, it does not have to be written. The base doesn't. Now, number 4 is the cube root of E equals 1.40. Does that E have an exponent on it the way it's written right now? It doesn't, does it? Here's a question. Can I turn that cube root into an exponent? Think about this. The square root of, we'll say 4. Isn't that the same? What's the index here? 2. What's the exponent on that 4? A 1. Power over root. Isn't that the same? Okay. So if I have a cube root, then how could I rewrite that as an exponent before I take it to, it would be e to the 1/3. Okay, so that's the very first step here, is you've got to get that radical and turn it into an exponent. Now take it to log form. Anytime you see a radical, that can always be turned into an exponent. Now that my base is written with an exponent, we can draw our L and write our natural log. It's going to be the natural log of 1.4 is going to equal, what's my exponent? 1/3, yeah. Again, you can write the little base E there if you want to, but that is not necessary. Other than having a base of E and writing LN instead of the word log, is there any difference here than what we've done? All right, we're going to simplify now, or evaluate. Simplify means the same thing. Take a minute and write these down. I'm going to do the first one with you, then I'll let you try the other 2. And then we'll get to our calculator stuff. Okay, so think back when we did evaluated our logs on, what, Tuesday we did that? No, Monday. What was the first thing we had to do? We had to set it equal to make it an equation, we set it equal to x, right? And then we had to get it out of log form by taking it to exponential. But keep in mind, if it's a natural log, they are not going to write the base. Even though there's an E, that E is in the argument. So there is also another E as your base that's not written. So we want to take it to exponential. E to the x power is going to equal e to the 10th power. Do I have the same base on both sides? Yeah, so when we have the same base, we drop the base and set the exponents equal. So what is x going to equal here? 10. try 6 and 7. Again, neither of those has the base written in, so I would recommend you writing it, then take it to exponential, and then work on solving for x there. Also, if you came in later, make sure you have a calculator, because we're going to need a calculator for the next work, and I need to just make sure that if you're using a different calculator, because some of them have to enter differently. Simplifying number 6 and 7, set it equal to x, take it to exponential. You're wanting to get the same base on both sides, and in this case, that base is going to be e. Base is e is there. We're going to take it to exponential. E to the x equals 1 over e to the 6th. Do those bases look the same right now? Where's the e on the right side? It's in the denominator. How do we make it come to the top? What do we do with this exponent to be able to make that e come to the top? Make it I'm trying to write, sorry. Negative, right? And how we make something move is we change the exponent to a negative. Hey, yes. Can you give me about 5 minutes? Just when we're done, then you'll see in guidance. Is everybody okay with how I made that exponent negative to bring that e to the top? Do I have the same base now? Yes. So we can drop the bases and we can set our exponents equal. So x is going to equal, or this log is going to simplify to be -6. All right, same thing with 7. I'm going to write my base in, set it equal to x, take it to exponential. Let's see if you guys remember. When my argument is 1, whether it's a natural log or a regular log, we talked about this is going to simplify to be 0. Anything to the 0 power is 1, even if it's e. Do we kind of see how all of these are the same? Just changing the base and changing what we have to deal with. Okay, and then the next thing is going to ask us to find the decimal value of some logs. Okay, so there's 2 buttons we need to look for on our calculator. You need to, on calculators like mine, okay, which are the ones up there, you're going to look for the log button, which is right below your second. So everybody see where it says log? And then you're also looking for the LN button, which should be right below your log button on most calculators. Some of your calculators, they're in the same button, so you have to hit it twice. So if you're not sure where it is, just let me know and I can show you. But it says we're going to approximate the common logs and natural logs using a calculator. We're going to round to 4 decimal places if necessary. So if it goes past 4 decimals, we're going to round it to 4 decimal places. So it'll take a minute. Maybe just go ahead and write all 6 of those down real quick, and then we'll talk about how to do it in the calculator. want to tell us on our quiz too, to use the calculator to find the value of them. So that's how you know when you need to use the calculator. So from what I see, everybody is using a calculator that is straightforward, which means we don't have to do anything backwards. So when we get to the point of evaluating these, you're going to type in exactly what it says up there. If it says log, you're going to hit the log button. Then you're going to push the number, and then you're going to hit equals. And you're going to round it to 4 decimal places. If it says LN, you're going to hit the LN button, enter the number, press equals, round to 4 decimal places. It's just a matter of pushing buttons in the calculator. Just make sure if it says log, you press log. If it says LN, you press LN. So if you want to go ahead and start working on those, again, from what I can tell, everybody's calculator is straightforward, entered as it looks. Log of 23 equals natural log of 23. So on and so forth. If it goes past 4 decimal places, round it to 4. But if it doesn't go to 4 decimal places, just give me what it says.
So, yeah. So for the next about 1, 2, 3, 4. So you want to look there. It says the number behind it. I think that's all.
All right, so I'm going to press on my calculator the log of 23, and I'm going to hit equals. Now I'm going to write what it shows me in my calculator. This is not the final answer. I just want to talk to you about rounding. Okay, so when I punch the log of 23 in my calculator, I get that decimal, 1.3617278836. When we round to 4 decimal places, you're going to look at the 4th number behind the decimal, and then you're going to focus on the number behind it. If the number behind it is 4 or less, that 4th number will stay the same. If the number behind it is 5 or higher, that 4th number will go up 1 digit. So bless you. In this case, is that 7 going to stay the same or change to an 8? Stay the same. So my final answer is going to be 1.3617. And yes, I will take points off on the quiz if you don't round properly. Make a little bit of sense? All right, keep going. If you haven't done all of them, finish. Press them in the calculator, round your answers. This is the easy part. Let the machine do the work for you. Before we had calculators, in order to do logarithms, let me see if I can find it. You had this chart that you had to look up the values of and then try to round if it were in between. Okay, so thank goodness we have technology that does it for us now. We don't have to use a chart that looks like this to try to figure out what our logs are. All right, so for number 9, again, I'm just going to hit the LN button, natural log of 23. And I'm going to round that to 4 decimal places. 3.1355. Is that what everybody else got? Okay. If you're not getting it in the calculator, let me come look, see how you're entering it. Okay, these should be give me questions on the quiz on Tuesday. We should not be missing these because it's just pushing some buttons. Then I'm going to do the natural log of 260. So I get 5.560 what's that last number going to be? 7, okay, because there's an 8 behind the 6 that makes it turn to a 7. And then I'm going to do the log of 260. That's going to give me 2.41. Uh-oh, what happens here? Hold on. 2.4149.7. Okay, so we're looking at this fourth number. That 7 is going to make that 9 turn to a what? A 10. And when that turns to a 10, we actually have to give the 1 over to this next one, right? So that's going to turn into 2.4150. So be careful if you're rounding up a 9. That will not only change the number in front of it, or that number, it'll change the number in front of it too. Then I'm going to do the natural log of 0.00025. And this time I get a negative number, which is okay. It's going to be 82940. Did everybody get that? All right. And then we're going to do the log of 0.00025. And that also gives me a negative 3.6021. Anybody have any questions?